Hi everybody, this is Mrs. Kraus, and this is our second of two videos on the Unit 2 Part 2 Notes, Properties of Water. So the next property of water, which you've probably noticed before, is that water in its solid form, or ice, will float in a glass of liquid water, like you see right here. If it's not floating, then there's something else mixed in with that ice that you want to avoid. Anyway, because it's floating, that means the ice is less dense than the liquid water it's sitting in. Why does that happen? Well, as water cools and solidifies into ice, more hydrogen bonds will form between the water molecules, which actually pushes them farther apart. If they're farther apart and there are fewer water molecules in a given space, that means it's less dense. So, these are hydrogen bonds forming between these water molecules, and when enough hydrogen bonds form as water cools, they get pushed apart and they form this lattice-like structure. So we often call this the crystal lattice of water molecules. And this shows you liquid water and ice side by side. You'll notice that when more hydrogen bonds are forming, the water molecules are farther apart, making ice less dense than the liquid water. A couple slides back, it had a question, why might it be a bad thing for ice to sink in a pond? Well, think about what happens in the winter. You have an ice layer form on the top of the pond, and it floats. That kind of insulates the water below it and prevents the water below it from getting too cold. That allows your fish and other organisms to survive during the winter time. If you had ice forming at the top that then sank to the bottom, you would have ice form at the top again because it's in contact with the cold air, and that ice would sink. Then the water on the surface would again freeze, and that ice would sink, and so on and so forth until your pond was solid ice. Obviously, that would not be a good thing for the organisms that live there. Okay. The last property of water is that water absorbs a lot of heat energy from the air without having a big temperature change. In other words, water has a high heat capacity. The reason it can take in a lot of heat energy without having a big temperature change is because it takes a lot of energy to break the hydrogen bonds between water molecules, which is necessary before that water increases in temperature. So a lot of the heat energy is used to break those bonds before we can see a temperature increase. For that reason, lakes and oceans are often going to stabilize air temperatures. I grew up on what am I trying to say here? I grew up right on Lake Michigan in Chicago, and it was often a lot cooler near the lake in the summertime. And that's because water's high heat capacity was preventing the areas near the lake from getting too hot. The same is true in the winter. It's often a little bit warmer during the winter by the lake, and that's because, again, water doesn't change temperature easily. So even though the air is changing temperature, the water is not as quickly. Additionally, when we sweat, water absorbs a lot of heat energy as it's trying to convert from the liquid form in our sweat to water vapor in the air. So as it evaporates, it's taking a lot of energy in order to do so. That's why sweating is going to help cool us down. This is kind of showing you why water has a high heat capacity. I'm showing you water as a solid with several hydrogen bonds between the water molecules, water as a liquid with a couple hydrogen bonds, and then water as a gas, which has a lot fewer hydrogen bonds, and the water molecules are moving around really quickly. Now, when water is converting from a solid to a liquid, so when it's melting, or when it's converting from a liquid to gas, it's becoming water vapor, we only see a very slight temperature change during those transitions, even if we have a really high heat exposure. That's because all of that heat is being used to break the hydrogen bonds to convert water from one form to another. So even though we're having a lot of heat energy taken in, during these transitions, or what we call phase changes, you're not going to see a corresponding temperature change in the water itself. Okay, and that's it for properties of water. Thanks, guys.